Okay, geometry students, today we are doing lesson number 3, and today we're going to be talking mostly about the segment addition postulate. So, your essential question, how can you use algebra to calculate the lengths of segments? So we do delve back into the world of algebra today, and your learning target, calculate values and lengths using that segment addition postulate. So just a few things here. Again, what is the segment addition postulate? One thing that I like to do a lot this year in geometry is I like to use a program called Geometer Sketchpad to help you understand really what's happening here. So here, notice I have a segment. I have segment A, C, and it's just kind of broken up. I've got point B in the middle, so it's kind of these two segments together that make AC, AB and BC. AB measures, it's 5.18, BC is 15.74, and then the total thing is 20.93. And lo and behold, if you add together AB plus BC, you get 20.93, the same thing as AC. And not only is this true for this particular example, but it's also true if I move things around. If AB is 1.78, 19.14, it's still 20.93. And it's still equal to the two of them added together. In fact, they will always be, the two of them added together equal to the whole. It doesn't even matter if I change this, if I make it a different angle. That will always hold true. And so this is called inductive reasoning. We'll talk more about that in chapter 2, but this should be pretty convincing for you that if I have two segments that make up a line, I add them together and it equals the whole thing. All right. So, ultimately, what is the segment addition postulate? Well, if I have a segment, AC, and I've got B somewhere in here, then AB plus BC is equal to AC. That is the segment addition postulate. That's a big idea today. Congruent segments, make sure that, so if we have something like this, congruent segments, make sure that you have little dash marks there. That's the indicator that they're congruent. They are not congruent until you have those symbols that ensure that they're congruent. And then how would we maybe describe that? Well, if we had like A, B, C, D, we would say that AB is congruent. So that symbol right there, that's the congruent symbol, and is equal to CD. Right? So the equal sign with a little wavy. Midpoint is exactly what you think it should be. Midpoint, if I have a segment, the midpoint, so here we call it segment AB, midpoint, call it M, is the point that cuts it in half, that will make AM congruent to MB. So AM is congruent to MB. So that's what we've got going on today. How's that going to turn out in examples? So here we have a segment, and oh man, those are X's. We're back in algebra land. So if Ln equals 32, what are Lm and Mn? Well, using the segment addition postulate, I know that Lm, if it's 3x plus 8, and if I add that to Mn, 2x plus 4, this would have to be equal to the whole thing, which is 32. Now I can use some of my algebra skills that I perfected last year to write an equation and solve. So combine my like terms, 3x plus 2x is 5x, 8 plus 4 is 12. This is all equal to 32. Now I have one of those beautiful two-step equations. I'm going to subtract 12 from both sides. And I've got 5x equals 20. Divide both sides by 5, and x equals 4. Now, are we done? The answer to that is no. This didn't ask me to solve for x. It asked me what are the lengths of Lm and Ln. So I need to take this 4 and plug that back in. So here I have 3 times 4 plus 8. Right? So my final answer, Lm is, well, 3 times 4 is 12. 12 plus 8 is 20, and then mn, right? Well, mn, I would also plug in 4 if I needed to. 4 times 2 is 8, 8 plus 4 is 12, and of course 12 plus 20 is 32. So this right here is my final answer. I would say for the first semester, that's a real common mistake that students stop when they solve for x. Make sure that if you are asked to, you go back and plug those in. All right, now here's technically another version of the segment addition postulate, but this time we don't know the whole length of it, but we have been told that S is the midpoint. And because it's the midpoint, I know that this is congruent to that. If they're equal to each other in length, instead of adding them together, I can just set them equal to each other, 3x plus 1. And now again, I use my algebra skills to solve for x. And you put all the x's on one side, I'm going to subtract 3x. And now I've got 4x minus 3 equals 1. Now I'm down to that old faithful two-step equation. I'm going to add 3 to both sides. Now I've got 4x equals 4, divide both sides by 4, and x equals 1. Again, we can't stop here. It says, what are rs, st, and rt? Well, if x equals 1, I'm going to plug that in. So I got 7 times 1 minus 3. Now let's see, rs. 7 times 1 is 7, 7 minus 3 is 4. I'll just take for granted that I know these are congruent, so st equals 4. I suppose if I plugged in 1, I would find that it was 4. And put them all together to find rt, and that would be 8. So that is my final answer, and this is all I'm showing you in regards to the segment addition postulate.